something for you to bear in mind. In order for you to differentiate at a point, you need that point to be continuous. And what I mean by that is, let's say you've got a graph here. This is your graph f of x here. If you want to differentiate, let's say at E here, you need this point here to be continuous. And what I mean by continuous is that you can draw across that point without lifting your pen off the paper. So if you look at this point E here, this here is not continuous, and in order for a point to be continuous, you've got to take this into account. If you take the limit from the left hand side, meaning looking at the point E here, if you take the limit at E here, that means if you approach it from the left hand side here, it's approaching this point here, and then you got to then take a look at the limit as it approaches from the right hand side. If the two approaches the same point, that's a good sign. Also, you need f of wherever you want this to be. Let's say E here. You need f of E to be defined and at this point here. Then this here will be continuous because this point E here, because f of E here is right here. It's not equal to the limit here. It's not equal to the limit here. It's down here somewhere. So this point here is not continuous. Really, in order for you to draw across that point, you need to take your pen off the paper, because look, starting here, if you draw it here, and then you need to lift it off, lift your pen off the paper, draw it here, and then jump back to here, and then continue this bit here. So this point at E here is not continuous. If you look at this, if you look at the point A here, you got to check it. You got to check that the limit from the left hand side. That means you start here. The limit from the left hand side, it's right here. Now you got to check this, the limit from the right hand side. So you start here and approach it from the right hand side. You see that they're meeting at one particular point, and then also you got to check f of a. When you do f of a here, f of a will immediately take you to this point here. You see that point there is equal to this and this, so therefore this here is continuous. Okay, even at point B here, check this. So for the limit from the left hand side, you start here, approach B here, approach B, it would take you to, hang on, start here, approach B, it would take you to this point here, and then you need to check it from the right hand side. The right hand side, let's say you start here, approach it from the right hand side, it's heading towards the same point. And look at this here, if you put B into the function here, it will immediately jump, you will immediately jump to here. So look at this. This from the left hand side, it equals the right hand side, and also dead on B, it equals this and this. Therefore, this point here, the point B here, is continuous. Okay. If you look at point C here, first check the left hand side. Left hand side is approaching here. Okay. And then from the check from the right hand side. From the right hand side, it's approaching there. So that's looking good. Okay, but the thing is, when you put C into here, C is actually undefined. That's when you put, you can't actually put C in here. It's not even in the domain. It's not defined. So therefore, this here, when looking at this, you can see there's a gap in there. So it's not really continuous. You do need to take your pen off the paper and then put it back here and then continue your journey. So this point C here is not continuous, even though this meets up with this here, but f of C is undefined. So this point here is not continuous. Okay, if you look at point D here, first check this point D. The limit as it approaches D here is heading here. The limit, then check this here, the limit from the right hand side. It's already at a different point here, so it's pointless checking this middle part. This here is not continuous. This point here, okay, this point here is not continuous. And whenever you have an asymptote like f here, okay, you check it from the left hand side. It's approaching infinity, and then you approach it from the right hand side. It's also approaching infinity. But the thing is, dead on f is undefined. Whenever you have an asymptote like this, dead on f is undefined. It's just like your y. It's just like your y equals 1 over x. It will look like this here. But dead on 0 here. You can't have x equals 0. You cannot have x equals 0. Dead on 0 is undefined. Just like this thing here. Just like f here. Just like f here. Dead on f. Dead on f here is undefined. You cannot put f into here. You cannot put f into the function. The function will just break down. So f here is undefined. So even though this is heading toward the same point as this thing here, f is undefined. In order for a function to be in order for it to be continuous at a point, it needs to approach the same point from the left hand side and from the right hand side, and also f of whatever at that particular point. It needs to be the same as this, and it needs to be the same as this. Okay, so bear in mind that in order for you to differentiate at a particular point, that point there needs to be continuous. It also needs to be smooth as well. But I will explain that smooth condition in another video. Okay, but just bear in mind that for something to be continuous, the limit must from the left hand side must equal from the right hand side, and also dead on that point it needs to be defined, and it needs to be equal to this and this. Okay.